Okay, so there's a point of confusion that we're going to have that we need to clarify right now. And that is that when most people think about the term acceleration, they think that that means that something is speeding up. If I'm accelerating, I'm speeding up. But in physics, that's not true. In physics, if I say acceleration, that only means that the velocity is changing. It could be increasing or it could be decreasing. Okay? And we oftentimes don't make that very clear. I need you to understand right up front that acceleration could either be an increase in velocity or a decrease in velocity. Okay? Now, if we have a decrease in velocity, we do give that a special name. We call that deceleration. I'm decreasing the velocity. Okay? I'm decreasing the velocity. So deceleration is the term that we use to describe slowing down. My velocity is decreasing. And it doesn't matter what the direction of motion is. If I'm slowing down in the positive direction, I'm decelerating. If I'm slowing down in the negative direction, I'm decelerating. Okay? So it doesn't really matter. If I'm slowing down, I'm decelerating. Okay? So I need you to understand that. And again, that's as opposed to acceleration, which could either be an increase in velocity or a decrease in velocity. Okay? Acceleration doesn't just mean increasing velocity. Okay? Now, we also use the terms positive and negative acceleration. Okay? If I have a positive acceleration, the acceleration is occurring in the positive direction. If I have a negative acceleration, the acceleration is occurring in the negative direction. It doesn't mean that negative acceleration is not the same thing as deceleration. Negative acceleration is acceleration in the negative direction. Okay, so we have to clarify all of these things right up front, and I want to walk through this just to make sure that we understand this. Okay, so let's suppose that our first scenario is an object that's moving in the positive direction and it's speeding up. Okay, so if I write a motion diagram that describes this, okay, so there's my origin and here's my positive x direction. Okay, so object is moving in a positive direction and it's speeding up. So short arrow, longer arrow, longer arrow, longer arrow. Okay, so there's an acceleration because it's changing its velocity, so there's an acceleration, and the direction of the speeding up is also positive. So we're going to say that the acceleration is positive. It's in the positive direction. And that means the velocity vectors are increasing. The acceleration is also going to be in the positive direction. Okay? So it's not decelerating and the acceleration is positive, and this is a case that makes the most sense, right? This is what everybody thinks about when they think about acceleration. Okay, not decelerating, it's the acceleration is positive. Okay. Okay, so what about this scenario? If an object is moving in a positive direction and is slowing down, so let's draw that. Object is moving in a positive direction but is slowing down. My velocity arrows are going to do this. Okay, so moving in a positive direction and is slowing down, then the acceleration is in a negative direction and the object is decelerating. Okay, so acceleration is this way. So velocity vectors are this way and acceleration is that way. And we can see why this makes sense if we think about it. If the acceleration was in the positive direction, then the object would in fact be speeding up in the positive direction. So it takes an acceleration that's in the negative direction to cause this object to slow down. Okay? Now, a way that we can always know what direction the acceleration is going in is if we write out what's happening to the velocity. If we make our acceleration arrow point toward the direction where the velocity lines are getting larger, then that will always be the case. Even though the velocity arrows are pointing in the positive direction, they're getting larger in the negative direction. So that's the direction I should draw my acceleration arrow. My acceleration will therefore be negative. Okay, so if you always draw out your velocity arrows to show what's happening, then you can also immediately draw an acceleration arrow to know what direction the acceleration is. So if you were given a fact that the acceleration was 5.0 meters per second squared, for example, and you weren't told that it was in the negative direction, but you noticed that the object was slowing down in the positive direction, you would know that you would need to put a negative in front of the acceleration value. Okay? So this is what's going on if the object is moving in a positive direction and is slowing down. The acceleration is in a negative direction, and the object is decelerating. Notice that deceleration is not the same thing as negative acceleration. Okay, so deceleration just simply means that it's slowing down. Negative acceleration means the acceleration is acting in the negative direction. Not the same thing, right? Okay, so go on to the next scenario. Okay, what about this situation? What if the object is moving in the negative direction and is speeding up? What's the situation then? So again, we draw our motion diagram. We have our positive values to the right, and we know the object is in a negative direction. It's moving in a negative direction, and it's speeding up. Okay, and it could cross over the line there. Okay, so it's speeding up in a negative direction. Okay, so obviously it's not slowing down, right? It's not slowing down, it's speeding up just in a negative direction. So it's not decelerating, and the acceleration has to be in the negative direction, right? The acceleration arrow has to be in the direction of increasing velocity arrows. And this is the direction of increasing velocity arrows. So this would be the situation where I have a negative increasing velocity, which means my acceleration is in the negative direction. Okay? Finally, if an object is moving in the negative direction and slowing down, the object is decelerating and the acceleration is in the positive direction. So let's draw that motion diagram. And so, object moving in the negative direction and its velocity arrows are decreasing in length. That means the acceleration arrow has to be pointing in the direction of the increasing lengths of the velocity vectors, so that acceleration has to be positive. Okay, so it is decelerating, but the acceleration is positive, and this particular scenario can be especially confusing. Again, the motion is velocity in the negative direction, and it's a decreasing velocity, so it's decelerating, but at the same time the acceleration is in the positive direction. If you think about it, if the acceleration was in the negative direction, it would cause the object to speed up in the negative direction. Okay, so this is that last scenario, and hopefully it won't take you very long to become a little bit more comfortable with these ideas, but they're very confusing at first unless someone sits down and tells you about them very explicitly like this. So go ahead and continue on with the actual video.